So let's take a look at some of the homework from section 2.3 from the My Math Lab. Now with these, I've just picked out some of the ones that I found more interesting, or perhaps I haven't done examples exactly like this. And let's see, the first one. So find secant of 69 degrees and 12 minutes. So first of all, my calculator doesn't have secant. So I'm going to have to use 1 divided by cosine, 69 degrees, 12 minutes. All right. So first of all, my calculator is in degrees. Let me change the thing so you could see it better. So 1 divided by cosine. And then I need 69 degrees in 12 minutes. Well, if you look right here, can you see it? If you look right here, it says angle. So put second angle, and then you've got degrees and minutes right there. Okay, let me go back. I need to type in the 69 and then put second angle, degrees, and 12 minutes. So I have to go second angle and then minutes. So I get a 2.816. So when you go to do this, of course, they're probably going to change the function or change the numbers, but essentially that's what you do. Now, another way to do this is right here, you could have written it as 69 degrees plus 12 over 60, and then that would change it to degrees. And you could either type it in just like that, or you could even get a decimal for this. So 69 plus 12 divided by 60. And once again, the screen is hard to see. So 69.2. So I could also go 1 divided by cosine of 69.2. And I still get the 2.816. All right. Then what about this one? Well, it's essentially the same, but I have to use 1 over, instead of cosecant, it's going to be 1 over sine, and then negative 112 degrees, 55 minutes. So I wanted to do this one because it's got that negative. So 1 divided by sine, and then negative 112 second angle degrees, 55 second angle minutes, and that equals a negative 1.086. Now I could also do the same way that I did it with this one and change this right here, this 55, to a fraction. So I'd need to go 112 plus 55 over 60. And then it's going to be that fraction. Now with this, I don't want to type in the decimal. I want to just use that whole thing because the calculator actually remembers this out to 13 decimal places. So what I'll do is go 1 divided by sine, and then right here, it says answer. So if I put second answer, it's going to type in this last answer. But I need to remember the negative sign. So negative, and then put second answer. And then I get the same thing, negative 1.086. Okay. Find a value between 0 and 90 degrees where cotangent equals this. Well, my calculator doesn't have cotangent, so I can't use that. So what I'll need to do is, it's going to be 1 divided by tangent of alpha equals the 1.4 4.32577. And at first I would write that over 1. And then I invert this side so that it becomes tangent of alpha. If I invert this side, that means I need to invert this side. So it's going to become 1 divided by 1.443257. Now, to solve for tangent, you use tangent inverse. So I'm going to need tangent inverse of this fraction right here. So tangent inverse of 1 divided by 1.443257, and I get 34.717 degrees. Now they said to use 6 decimal places, so what I'll do is just go to mode, change the float to 6 decimal places, and redo this. Well, I don't feel like typing it again, so I'm just going to go like this and get a screen grab of the same thing. And so it would be 717 and then 196 going to 6 decimal places. All right, so did you know that you could print out all of the homework questions? So all you do is open up the first homework question, and then it says homework help over here, or question help, something like that. And when you do, the very last thing is print. And you could either print one question at a time, or you could print out all the questions, which is what I did here. So that's not just a teacher's option, and that should be open to the students as well. Okay, use a calculator to decide if this is true. Mostly I want to do this one because I want to make sure you know how to input this in the calculator. So one side says cosine of 12 degrees. So one side is a 0.978 and then 148. The other side says 2 times cosine squared. So to input cosine squared, you have to put the cosine of 24 degrees, close the parenthesis, and then use the squared button right here. And then it said minus a 1. And the other side is a 0.669, so those are not equal. What's next? Ah, yes. So the reason I chose this one is because it says find all of the values. So this right here is saying that cosine is equal to a positive. So if you do the A Smart Trig class, cosine would be positive in the first quadrant and then the fourth quadrant. So there's going to be 2 answers. The way to get the first answer is use cosine inverse. So I need cosine inverse of this decimal. So cosine inverse of the decimal 0.58644416. And so one answer, how many decimals did they say? Round it to the nearest degree. Round it to the nearest degree. So this would get rounded to just 54 degrees. So one answer would be 54 degrees. And that would be in the first quadrant. Now the idea is, how do you get the answer in this quadrant? Well, if 54 degrees is this reference angle right here, then what you could do is start right here, go around until what's left is 54 degrees. That's how you get to the fourth quadrant, which means that this angle is going to be 360 minus 54. And a 60 minus a 54 is a 6. So that would be 306. Use a comma to separate your answers. So just enter it like that. Okay, so that's what I wanted to go over in section 2.3, and now in section 2.4. So on 2.4, I'm going to go over the important ideas, but not necessarily every detail. So the first one I want to go over is this. So solve for angle B. Well, if this is 90 degrees and the three angles of a triangle add up to 180, that means this one and this one add up to 90. That means that this one equals 90 minus this. So how much is 90 degrees minus 21 degrees in 35 minutes? Well, basically this is like in probably third grade, second grade, you were taught to do subtraction using borrowing. So that's what I need to do right here. So I need to borrow 1 degree off this, which is going to leave 89 degrees. And that 1 degree gets converted to 60 minutes. And then subtract. So a 60 minus a 35, that would be 25. And an 89 minus 21 will be 68. And then to solve for, let's say, side A, so I can use this angle, and then this would be the opposite, and this would be the hypotenuse. So we'd have sine of 21 degrees, 35 minutes, is equal to opposite over the hypotenuse. And then to solve for A, I just need to multiply both sides by 969. So that would be 969 times sine 21, and then go to second angle, get the degrees, 35, and then go to second angle and get the minutes. And so that would be 356.451 if I go to 3 decimals. They said round it to the nearest integer. So with this being a 0.4, that would just be 356. So I also wanted to look at number 4, mostly just with this setup. It's basically the same as the last one that I just did, but make sure that it's set up right. So here's a right triangle, and it says that C is 90 degrees. And then I could put this as A, and this is B. And the A is 45.5 degrees. And then C, lowercase c, means that this side is 23.3 feet. And then this would be, across from B, this would be lowercase b, and this would be lowercase a. And then you could set up sine, just like I did with the last one, and then that's how you would get A. And for angle B, it's just going to be that this one plus this one has to equal 90. That means this one equals 90 minus 45.5. And you could even do that on a calculator, and you get 44.5 degrees. Okay, another one that I thought was worth taking some time to look at is number 7. So an isosceles triangle means that it has two sides that are the same. So let's say these two sides are the same. And then this is the base. And that would be 38.9. It looks like I might need another piece of paper. So I have an isosceles triangle. Isosceles, Greg. There we go, perfect, isosceles triangle. And the base is 38.9 38.9 inches. And then each base angle, so that's this angle and this angle, is 36.97. 36.97. And of course, the program is going to change these numbers, but the idea is going to be the same. Find the length of these two sides. So in other words, these two sides are the same, so solve for x. So to do that, what I do is cut this triangle in half. This line would be perpendicular to the base, and that means that this 38.9 just got divided in half. 38.9 gets divided by 2, so that means it's going to be 19.45 and 19.45. Now these two are just a mirror image of each other, so I don't really need to have both of them anymore. I just need one of them. So if we use this angle, that means that this is the adjacent and this is hypotenuse. So that's going to be cosine of 36.97 degrees equals the adjacent over the hypotenuse. Then what I could do is multiply by x, which would put it over on the left side. And then I could divide by cosine, which would put it on the right side. So then that would be, so I could just take this last number, 19.45, and just hit divided by cosine of 36.97. And then it would be 24.344. I prefer to go to 3 decimals. What do they say? Type an integer or decimal rounded to the nearest hundredth. So that means 2 decimals. The tenths, the hundredths, so I wouldn't need this. That would be my answer. Okay, then one more. Oh, we're at 17.5 minutes. My YouTube analytics tells me that people do not like to watch videos longer than about 18 minutes. And we're right about there. So just hold on a second. We're almost going to be done. A building is this tall. So this is going to be the building. This is going to be the ground. Is it on there? Okay, good. The building is 34.97 feet tall. And then it has a shadow. So the sun, sort of scary to make a black sun, but there's the sun. And then the sunlight would go like this, and then the shadow would be on the ground. So this is the shadow down here. And it has a shadow that's 37.94. I thought that I did it wrong, but they're using almost the exact same number. They just switched 34.97, good. 37.94, okay, I got it. Then find the angle of elevation. So that means if someone was standing at the tip of the shadow, and then they have to look up to see the top of the building, what is this angle right here? Well, for one, we need a right triangle, so we need to assume that the building is standing upright. And then once we have that, this is opposite and this is adjacent. So it's going to be tangent. Tangent of theta equals the opposite over the adjacent. And then to solve for theta, I just need to do tangent inverse. Well, now the screen is showing up just fine. The moment I'm up, oh, I see. Because my calculator was falling asleep. Okay, so anyway, now I need to do tangent inverse. So tangent inverse of a 34.97 gets divided by 37.94. And so then theta equals 42.667. And they said to go to the hundredth, so that means the second decimal. Well, for this one, that means that it's going to get rounded to be a 42.67.